Hello everyone, welcome to the first chapter of Huawei HCIP OpenELR certification course. This section, we will continue to learn the common service management of OpenELR. After learning the precision section, we are familiar with HTTP and HTTPS and the principles of web service. With the help of practice, we have mastered the installation and test of Apache service. And also for main page configuration, DSO loading and unloading, NPM mode adjustment, persistent connection setting and static resources configuration, virtual host configuration, and HTTP implementation. You can operate and practice after the class. And now we are starting in this section. We will introduce another web service, Nginx.
Let's take a look at the second major web service, Nginx. In the current mainstream web server, Nginx has the highest occupancy rate. This is because Nginx is ideal for large-scale multi-concurrency scenarios. And Nginx is more lightweight than Apache, and it can also be used as a proxy server. In addition, Nginx can run on multiple platforms such as x86 and ARM, and supports mainstream operating systems such as Linux and Windows. So, what are the key features of Nginx? First, Nginx uses an asynchronous event-driven architecture. This means that it can handle thousands of concurrent connections in a single process. This architecture allows Nginx to maintain low memory and low CPU usage in high concurrency scenarios. One of these design goals is to support highest concurrent connection on common hardware. These features also makes Nginx very suitable for processing heavy traffic web services. One single node Nginx supports 100,000 concurrent connections and potentially up to millions of concurrent connections. Second, due to the lightweight design, Nginx consumes less memory when handling a large number of concurrent connections. Consuming only 2.5 MB memory from 10,000 inactive HTTP keep-alive connections. This allows it to run efficiently in resource-constrained environments, such as virtual hosts. And the optimized Nginx code ensures that as few resources as possible are consumed without sacrificing performance. Third, Nginx supports load balancing. It can distribute requests by configuring multiple backend services to improve the processing capability of the entire system. Like Apache, it has a modular design. The support of third-party modules further enhances its functionality, allows Nginx to be extended in various ways, such as adding advanced features through Nginx Plus. Finally, Nginx uses the master and worker mode. If a worker is faulty, the master can quickly start a new worker to provide services, ensuring high availability of the service. It also supports TCP and UDP load balancing and reverse proxy to provide datable services in complex network environments. So, in other words, high concurrency, low memory consumption, high scalability, and high reliability makes Nginx very popular in the Internet service field. It is not only suitable for large websites and services, but also suitable for load balancing, content delivery network, CDN for short, static resource hosting, and other scenarios. The Nginx architecture consists of one master process and multiple worker processes. First, let's look at the master process. The main process is the first process created when the Nginx server starts. It manages and monitors other working processes. The master process reads the configuration file, such as nginx.conf, and uses them to initialize the global state of the server. The main process is responsible for handling and managing work processes, such as starting, gracefully shutting down, monitoring the worker process status, and restarting the worker process when the exception occurs. The main process does not handle client requests directly. It is usually handling regular network events, such as receiving a TCP connection from the client. For worker processes are started by the main process according to the configuration file. Their number usually matches the accepted number of concurrent connections. By default, Nginx creates as many worker processes as CPU cores on the server. Worker processes are independent of each other. If one worker process is faulty, other worker processes are not affected. The worker process is responsible for handling the actual client requests. Each worker process maintains an event loop that listens on the specified port and socket and handles events as they occur. Using the asynchronous event processing model, the worker process can receive and processes new connection at the same time as it processes a request, which greatly increases server throughput. Worker processes are equal, and there is no special worker process. They all have the chance to process requests, which allows for load balancing and failover. This architecture design enables Nginx to process a large number of concurrent requests while maintaining low resources consumption. In addition, when the worker process is faulty, the main process can take over and restart the worker process, ensuring high availability of the service. In addition, this design allows Nginx to dynamically adjust the number of worker processes to meet different load requests without reloading the configuration. Next, let's look at the key working mechanism of Nginx. The key working mechanism of Nginx includes preemptive scheduling of worker processes and asynchronous non-blocking event processing of Nginx. These mechanisms are at the heart of Nginx high performance. So first, let's introduce them one by one. The first one, preemptive scheduling of worker processes. When a client initiates a request, the accept mutual exclusion lock is activated. The worker that preempts the mutual exclusion lock responds to and processes the client's request. And for the asynchronous non-blocking processing mechanism, it means that in the traditional event processing model, if all workers are blocked by the client, the new client needs to wait until the original client releases the worker before the request can be processed. But when we turn to the asynchronous non-blocking event processing mode, using the Linux Apple event notification model to detect the status change of I/O events. Even if the worker is blocked, new client requests will be processed normally. Asynchronous non-blocking I/O enables Nginx to handle thousands of concurrent connections without creating a separate thread or process for each connection, saving the system resources. It is the combination of this mechanism that enables Nginx to handle a large number of concurrent requests while maintaining low resources consumption and high availability. Nginx, like Apache, is a modular architecture. Nginx modular architecture allows it to be extended and customized very flexibly. The core module provides the basic functions of the Nginx server, and other modules provide additional functions, such as load balancing, caching, and security. As with Apache, the core modules are required for the Nginx server to run. They make up the basic framework of Nginx, and it include Nginx core module provides core Nginx functions such as configuration parsing, log recording, and error handling. And then for Nginx HTTP modules provides HTTP services, including processing HTTP requests and responses, and implementing HTTP parsing and construction. An Nginx event module provides an event-driven framework that supports multiple event modules such as A-Poll and KeyQueue. Besides this, Nginx Stream module provides a TCP and UDP stream processing module and supports TCP and UDP proxy and load balancing. There are also error log modules, Nginx OpenSL module, Nginx Mail modules, and so on. Of course, there are many more standard modules, and the ones listed in the figure are only representative. Other modules also provide additional functionality to Nginx and can be added by the requirement. For example, Nginx HTTP-SL module provides SSL and TLS support for encrypted HTTP communication. Nginx HTTP gzip module provides gzip compressions to reduce the size of responses and improve transmission efficiency. HTTP rewrite module provides the URL rewriting function to modify URLs based on the specified rules. HTTP proxy module provides the HTTP proxy function to forward requests to other servers. HTTP upstream module provides load balancing support to distributed requests among multiple backend servers. Nginx HTTP cache module provides the cache function to cache common static content and reduce the load of backend servers. The module design allows Nginx to maintain high performance while adapting to different application scenarios and requirements by adding or replacing modules. Actually, Nginx also have two very powerful features, that is, proxy and load balancer. We will focus on these two functions when we are talking about clusters in Chapter 2. Now, let's take a brief look at them. Nginx can act as both a reverse proxy and a forward proxy. The reverse proxy workflow is divided into 4 steps. Let's see. Step 1. A client sends a request to Nginx, and after receiving the request from the client, Nginx forwards it to the backend server. The backend server returns the requested resources to Nginx. And then, finally, Nginx returns the resource to the client. The proxy function of Nginx is implemented through proxy path in location. In addition, the process of acting as the reverse proxy, the port used by the client to request resources from the proxy can be different from the port used by the actual server to provide services. For details about how to configure the port, please see Chapter 2. And another important function is load balancing. The Nginx can provide Layer 4 and Layer 7 load balancing. This function is implemented by the upstream configuration module in the configuration file. When used as a load balancer, Nginx can distribute incoming requests from the front end to the back end using various load balancing algorithms. For example, when the road bin algorithm is used, Nginx sends requests to different servers in turn so that each server provides services equally. When the wait algorithm is used, Nginx sends requests to the server based on the configuration weights. Servers with good performance provide more services, and servers with poor performance provide fewer services. And next, let's practice using Nginx. Nginx can be installed using yum or by compiling the source code. Like other applications, yum is easy to install but lacks flexibility. Source code installation is the opposite. And for this picture, we introduce the first method. We run yum install -y Nginx command to install Nginx. And from this picture, you can see after the installation process complete, we can use Nginx properly. But if you choose to install by the source code method, you need to download the source code package of the corresponding version from the following path. Install the tools required for compilation and run the command make and make install to install the tools. During compilation and installation, you can select a version suitable for production and customize the installation path, optional modules, and third-party plugins. For example, if the web server built by Nginx needs to be accessed through HTTPS, you can install OpenSL during compilation. If HTTPS is not used, you do not need to install OpenSL. This reduces the waste of hardware resources.
This section describes the features, running architecture, working mechanism, and modules of Nginx, as well as the reverse proxy and load balancing functions of Nginx. In the next section, we will install Nginx and configure Nginx static resources, virtual hosts, and routing rules. Of course, we will verify the reverse proxy and load balancing functions in the hands-on demonstration. Thank you for watching.